The next property, it is the fourth one, it is oxidation state. Oxidation state. Okay, listen. So, what do you mean by oxidation state? The removal of electron, boron exists in plus 3 oxidation state. So, all the family, that is boron, aluminum, gallium, indium and thallium, all are exhibit plus 3 oxidation state. Now, boron and aluminum shows only plus 3 oxidation state. Plus 3 oxidation state. Now, in the case of gallium and indium and aluminum, plus 3 oxidation state stability is decreases and plus 1 oxidation state stability is increases. So, these 3 elements shows 2 oxidation state. It is plus 3 and in addition to plus 1. So, it is plus 3 and also that plus 1 and here plus 1 and plus 3. So, down the group, you take down the group, plus 3 oxidation state, plus 3 oxidation state stability, what is that? Stability decreases. Why? That is, in other way, we may take here AlCl3 is most stable, but TlCl3 is unstable. TlCl3 is unstable. Why? So, here what is the reason is the very important and unique property of P block is inert pair effect. What is that? Inert pair effect. Okay, what do you mean by inert pair? Here itself there is the answer. Pair. A pair of electron become inert in P block, which is known as inert pair effect. And you know that the general electronic configuration of 13th group is Ns2 Np1. What is that? It is 2 electron, it is p orbital, that is 3 p orbital, it has only 1 electron. So, here the pair, what is that? The Ns electron is nothing but a pair. This pair of electron is become inert, these are become inert, which is not involving bond making, not involve bond making, then it is known as inert pair effect. So, what is the definition of inert pair effect? In a P block elements, the outer Ns electron become inert, which is not involving bond making, which is known as inert pair effect, and this inert pair effect down the group increases. Down the group it is increases. So, here aluminum is exist in plus 3 oxidation state, so that it is correct, but thallium is exist in plus 3 oxidation state, it is wrong, so that it is unstable. So, aluminum is AlCl3 is most stable because there is no inert pair effect, but in TlCl3 here thallium is shows or probably shows that it is plus 1 oxidation state, so that TlCl3 is unstable. And one more question, and if you have taken Tl plus and Tl3 plus, among these which one has best oxidizing agent? Best oxidizing agent. And so, we may compare this one, which one has best oxidizing agent. Oxidizing agent. Okay. Now, we may compare that best oxidizing agent is one which can easily accept an electron. So, comparing the stability of TL plus 1 oxidation state and TL plus 3 oxidation state, which one is more stable? Here, it is a stable because of inert pair effect, and it is unstable. It is unstable. So, plus 3 oxidation state is unstable down the group because of inert pair effect. So, comparing TL plus 1 and plus 3 oxidation state, which one is stable? TL plus. So, TL3 plus accepts 2 electron and become that TL plus 1, so that TL3 plus is accepting electron because of stability, so that it is a best oxidizing agent. It is a best oxidizing agent, so it is oxidation state. And why the inert pair effect is occurs? We may take in detail for inert pair effect. Listen, we are taking that NS2 NP1 electronic configuration, NS2 NP1, and it is 2 electron and p orbital as 3 electron, and here only 1 in a ground state. In a ground state, it is NS2 NP1 electronic configuration of 13th group element. Okay. Now, it has only one oxidation state. So, only it is the unpaired electron. Unpaired electron. It is involving bond making. So, only the unpaired electron involving bond making. So, which one is involved bond making? The unpaired electron. Now, boron shows plus 3 oxidation state. So, all should be unpaired. So, there is a excitation. So, here in a excited state, what will happen? Here one electron is moved to p orbital. So, here 1 and 1. So, there are 3 unpaired electrons which is involving bond making. So, that for that excitation it needs energy. Then for that excitation it needs energy. This energy is nothing but excitation energy. Excitation energy. Okay. Now, any bond formation is exothermic nature. So, we are take bond formation. Bond formation. So, any bond formation is exothermic. What do you mean by exothermic? That is energy liberated. Energy liberated. So, any formation of bond, there is a exothermic energy, then it is known as bond energy. So, this exothermic energy which is known as bond energy. Okay, listen. Now, we may have two energy. One is excitation energy and another one bond energy. Bond energy is due to formation of any bond. Then excitation energy is due to unpaired the electron. So, NS electron, the pair become that unpaired. 2 electron become 1 electron. Pair become unpaired is nothing but excitation energy. Now, in the case of boron and aluminum, what will happen here? The bond energy is greater than the excitation energy. Greater than excitation energy, so that it shows +3 oxidation state. It shows +3 oxidation state. Okay. Now, in the case of gallium, indium and thallium. Gallium, indium and thallium. Then here the bond energy is less than the excitation energy. Bond energy is less than excitation energy, so that it shows +1 as a most stable oxidation state. And we are already discussed here d electron is there in a inner shell. Here also there is 3d electron and 4d electron and 4f electron is there. in the inner shells, so that it has very poor shielding. Again, it has very poor shielding effect, so that the nuclear charge is experienced by the last electron is highest, so the bond energy is least. Bond energy is least. So due to shielding effect and the bond energy difference, boron and aluminum exist as +3 oxidation state, and thallium as +1 oxidation state because of inert pair effect. Inert pair effect. So what do you mean by inert pair effect? The definition is the ns electron in p block elements become inert, which is not involving bond making. It is known as inert pair effect. Okay. And the next property, it is melting point and boiling point. Listen students, which one is a liquid metal? You know that? What is a liquid metal? It is mercury. Mercury is a liquid metal. You know very well. Then one more metal, it is gallium in 13th group elements. Gallium exists in liquid state at 29.8 degrees Celsius to 200 degrees Celsius. So we may take that the melting point. Melting point. The melting point is also some variation, and we are taking for that melting point. Here we may take a graph like this. We are take, it is boron, and here aluminum, and here it is thallium and indium, and here it is gallium. So we may take the order of melting point. What is it? Boron as highest melting point, because it is a polymer, and after that it is aluminum. What is that? Aluminum. After that aluminum, it is thallium. So what is that? It is thallium and indium and gallium. Thallium, indium and gallium. So gallium has the least melting point. It has a liquid at 29.8 degrees Celsius to 2000 degrees Celsius. So it exists as a liquid at a summer. In winter, suppose 29.8 degrees Celsius, below this temperature, it will be exist as a solid. So it has a high range 29.8 to 2000, so that it is used in high metal thermometry. So it is used in thermometric process. Thermometric process because of high range of liquid state. So which one is exists as a liquid metal? After that, that is mercury, gallium is exists as a liquid metal. Now we may take the boiling point. Boiling point is also some order is changed. It is boron, after that aluminum, and after that it is gallium, it is indium and gallium and thallium. So it is the boiling point order. Boiling point order. And the next one, it is electronegativity. Electronegativity. So what do you mean by electronegativity? And electronegativity is nothing but the relative tendency of an atom to accept the bond pair of electron towards itself is nothing but electronegativity. Now, the electronegativity in the 13th group from boron to aluminum, it is decreases, and after that, it is increases. After that it is increases. So we may take that it is boron and it is aluminum. So boron to aluminum, it is decreases, and boron, aluminum and gallium and indium, and it is thallium. So the order, what is order? It is boron. So electronegativity order, that is boron as highest electronegativity. After that, it is thallium. After that, it is thallium and indium and gallium and aluminum. So, aluminum has least electronegativity. So, these are the variation of properties of the element. And here the first element boron as a special character, it will be varied from all those elements. Why? Because, so we may take the next property, the seventh one, anomalous property of boron. Anomalous property of boron. So, boron in all property it will be varied. The first head of the family is varied in all those property because the first one, it has smaller in size, small size. So, size of boron is very small. And the second one, it has high ionization energy. We are already take that B3 plus does not exist because of high ionization energy. So, high ionization energy and electronegativity. And the third one, it is absence of d orbital. Absence of d orbital. So, these three reasons, the first element in all p block elements, suppose the first element in all p block, that is boron, carbon, nitrogen, oxygen and fluorine and neon, these are all the head of that p block element. They will vary from that the rest of the group because of these 3 points. What is that? Small size, high electronegativity and ionization energy, absence of d orbital. Okay. Now, we may take the chemical properties of boron. Chemical properties. So, the chemical properties of boron. The first one, here formation of boride. What is that? It is formation of boride. Formation of boride. Listen, when boron is reacted with chromium, a metal. The first one, direct combination. When chromium is reacted with boron and form that here CrBn times. So, any metal except alkali metal. So, here there is a exception. So, it is except alkali metals. Alkali metals. So, any metal except alkali metal form that is Mx and By type of borides. Mx and By. So, what is that Mx? Here x equal to 11 units and y equal to 66 units. Y equal to 66 units. Now, so here chromium is reacted with the boron and form that chromium boride. And here the second one, we may take that BCl3, boron trichloride. Boron trichloride is reacted with the tungsten at 1500 Kelvin in presence of hydrogen. In presence of hydrogen. Here we may take that tungsten boride. That is tungsten boride and chlorine gas is evolved and form that HCl. So that it is boride and here also boride. So formation of boride, that will be happen two ways. Direct combination and from BCl3. From BCl3. Okay. Then next one. Next one we are taking the formation of boranes. Formation of boranes. So, formation of boranes. What is that borane? Boron hydride are called as boranes. So, here boron is reacted with the hydrogen and form that boron hydride, which is known as borane. So, it is not a direct one. So, we are take BF3, boron trifluoride. Boron trifluoride. Boron trifluoride is treated with the sodium hydride at 450 Kelvin. 450 Kelvin. Then we are getting that it is diborane B2H6, B2H6 and NaF, B2H6 and NaF, and it is the simplest borane. It is the simplest borane. So the simplest borane is B2H6. So it is B2, so that it is 2, and 6 fluorine, so that here it is 6 and here also 6. So it is balanced. So the simplest borane is diborane. From that we may take the higher boranes. So higher boranes are prepared from the simplest borane, that is diborane. Okay. And the third one, reaction with halogen. Reaction with halogen. Then boron is reacted with the halogen and form that BX3 type of halides. BX3 type of halides. So what is it? Here 3 and 2. So that we are take 3 and here 2 and here B. And the next one, it is reaction with oxygen. Reaction with oxygen, most important reaction. When boron. Boron is not easily reacted with oxygen, only at a high temperature it is reacted with oxygen. So boron is reacted with oxygen and form that B2O3. So here 2 and 3, so here 3 and 2, so 4. And the same way we are taking, that is boron, aluminum is reacted with oxygen and form that Al2O3, so that it is 3 and 2 and 4. Now here we may take the oxide reaction. This is very important reaction. This B2O3 is acidic nature. B2O3 is acidic nature. What do you mean by acidic? When it is reacted with water and gives an acid. Suppose we are take B2O3. This B2O3 is reacted with water, H2O, and form that H3BO3. It is boric acid. What is that? It is boric acid. So boric acid, so that it is acidic character. Acidic character. Now Al2O3 and Ga2O3. They take Al2O3, Al2O3 and Ga2O3. These are all amphoteric. Amphoteric nature. What do you mean by amphoteric? Amphoteric has dual behavior. Is maybe reacted with acid or may be reacted with base. That is, it may act as a acid or maybe a base. Then it is known as amphoteric character. Then the remaining, what is it? In2O3, indium. So gallium, indium and thallium, Tl2O3, all are basic in nature. Basic in nature. So here acidic nature B2O3 and aluminum oxide and gallium oxide are amphoteric nature, and indium and thallium is basic nature. What do you mean by amphoteric? It may act as acid as well as a base. The next property, it is reaction with acids and alkalis. Acids and alkalis. Okay. Suppose we are taking a boron. Boron is not reacted with the haloacids like HCl. HCl there is no reaction. But it is reacted with the oxidizing agent. Oxidizing acids. What is that oxidizing agent? Nitric acid and sulfuric acid is oxidizing acid. So it is reacted with the oxidizing acid and form that H3BO3 and NO2. Then when boron is reacted with sulfuric acid and here also H3BO3 and sulfur dioxide. Now balancing the equation, it is 3 hydrogen, so it is 3 nitrogen, so that it is 3, and oxygen it is 9, so it is 6 and 9, so it is balanced. Now balancing the equation, here 3 and here it is 2. 3 sulfur, so that it is 3. So 2 boron and here 2 boron. So it is balanced. So when it is reacted with oxidizing agent and liberate nitrogen dioxide, when it is nitric acid, liberate sulfur dioxide if it is sulfuric acid. Okay. Then when boron is reacted with sodium hydroxide, is nothing but alkali. Then it will be gives sodium borate Na3BO3, sodium borate, and liberate hydrogen. So it is 3 Na, so that if it is 3 it is not balanced, so it is a 6, so that it is 2. So 2 boron and 2 boron and hydrogen 6 hydrogen, so it is 3 hydrogen. So with sulfuric acid, sulfur dioxide is evolved, nitric acid, nitrogen dioxide is evolved, with a base, hydrogen is evolved. So it is the properties of boron. Now we may take that uses of boron. And you know that bulletproof vest is made up of boron fiber. Bulletproof vest. So that here bulletproof vest is made up of boron fiber. Boron fiber. And the second one. And boron isotope B510. It has neutron absorber. Neutron absorber. So it is act as a neutron absorber. So that here in that boron rod, this B510 boron is used as a neutron absorber in nuclear reactors. So nuclear reactors, it will be act as a neutron absorber. And the third one, and boron compounds like borax and boric acid. All are as a plenty of uses, which is used as a eye drops. It is used in eye drops and antiseptic character, even in washing powder. And also this boric acid, which is used in Pyrex glass. Okay. And the fourth one, it is in that rocket fuel igniter. So amorphous boron, which is used as a rocket fuel igniter. So these are all uses of boron. Okay. So dear students, watch the video regularly, and after watching the video, go through your state board book and NCERT book and practice the evaluate question. And remember, never stops learning, because life never stops teaching. Thank you.